Hey, Nora. Hopefully you're doing well. Yeah, I got your response. And so what I'm going to try to do is record this either in one or two parts. I'm not too sure here. And so the first way I'm going to show you is the more of the traditional way of doing the stoichiometry problem. And then I'll show you my chart method, the Souter stoichiometry method of doing this. Okay, so this is my first time I've ever used an iPad or recording device, so you get to be the first. Yay! Okay, so it's been a little while since I've done this. Make this big enough so it's easy to see. All right, now it looks like you have the balanced reaction of propane, and so you have, oops, come on now, wrong thing. No, hold on. Sorry. All right, hopefully this is, no, come on now. Okay, so looks like we have propane, C3H8, and this is a combustion reaction, 5O2 yields 3 carbon dioxides and 4 waters. Okay, and you stated that you found the formula weight. Now, I'm going to do something a little bit different here, and I'm going to put down all the grams up here at the top. So you mentioned here that this was 97 grams. Actually, what I'm going to do is, oh, come on now. I'll make this 97.0 grams, okay? And we're going to find out the masses of the other things here. I'm not sure if you needed the mass or the moles, so guess what? We're going to do both, all right? And now if I messed up on the masses, or the molar mass of the materials here, just let me know. I can work on it again. So the traditional methods. So let's first find out, we're going to solve for this one first. Okay, then this one second, this one third. Okay, and you know what? I'm also going to put a section down here for moles. And that way we just kind of keep track of everything that we're doing. All right, so I sometimes think if you put things in kind of an organized sort of way, it makes things a little bit easier. So we have 97.0 grams of propane, C3H8. All right, I'm going to put this all over one. Now, I had a tendency of doing things maybe a little bit different, and that's okay. And the formula weight for propane is about 44 grams per mole. So now that's grams is equal to 1 mole, so I'm going to put 1 mole on top. And the 44.09562. I looked this up online here, and what happens here, the grams will cancel out. So you're going to take the 97 times 1, divide by 44.09562, and we get an answer of 2.19976 moles. Now, because this is your 97.0 is 3 significant figures, I'm going to round to 3 significant figures. So this value right here is actually going to come out to be 2.20 moles. Okay. Now, and this is still propane. All we did was we just converted the mass and found out how many particles of propane there are. Now, we're going to go from, if you look at that chart I gave to you the other day, we're going to go from moles of A to moles of B. And so, therefore, I need to go from moles of propane, and we're going to solve for oxygen next. So, I need to use the moles of propane. I need to use something that I do know in order to find something that I don't know. So C3H8, I'll put that all over one. And now I'm going to use the ratios here. So this is technically a 1, and I have 5. Okay, so it's 1 mole of propane to 5 moles of oxygen. So therefore, I got propane on top. I need to put propane on the bottom. So I'm going to put that 1 mole C3H8 and 5 moles of O2 on top. This way, not only moles cancel out, but so does the propane also cancel out. So I'm going to take 2.1997 times 5, and that comes out to be, what is it here? 10.9988 moles of O2. Okay, so whenever you're doing it, just make sure you always include not only the units, but also what is the substance. Okay, now I'm going to put that information. So again, 3 cent figures here. Look to the right, I have a 9, so therefore I round it up. So my answer here is going to be about 11.0 moles of O2. I'm just going to keep it the number I have right there, 10.9988. All right, now, next thing is I can find out, since I had the number of moles, I can now find out how many grams of the oxygen I have. So since I have the moles of it. So I'm going to take 10.9988 moles of O2 and put that all over 1. Now, if you look at that that flow chart, we're going to go, now oxygen is B, and so now I'm going to be using, I'm going to go from moles of B to mass or grams of B. So I need to use the formula weight, and the formula weight for oxygen is 31.99, depending upon which source you look at. I have 994 grams for every 1 mole of it. And that way, moles will cancel out. And when I do that, I end up getting a mass of 351.955 grams of O2. Okay, so I'm going to put that over here. So 351.9, well, okay, if it was 3 cent figures, then I guess we can also say that I'm just going to round this to 352 grams. Okay, so 3 cent figures here. Now, we need to find out how much carbon dioxide. So carbon dioxide is now going to become B. I'm going to change the colors here. And so I need to find out the amount of carbon dioxide, and I need to use a mole that I already know. Now, I actually have 2 choices here. I can either use moles of oxygen or moles of propane. So if I use oxygen, then I want to use the 3 and the 5 between these two. Okay, if I'm using propane, then I'm going to be using the 1 and the 3. Okay, so but in this situation, I want to go ahead and use the propane. Okay, so I need to use the moles that I already know. And if you look right here, this right here, here is the moles of propane. So I have to use a known in order to find an unknown. So I'm going to take the, what is it, 2.19976 moles of propane, identify what it is. I'm going to put that all over 1. All right, and that I'm going from moles of A to moles of B. So I'm going to go from moles of propane to moles of carbon dioxide. Okay, so I'm going to use the 1 and the 3. So therefore, I'm going to put 3 moles of CO2 all over 1 mole of propane, C3H8. Mole cancels out, and propane cancels out. And so 2.19976 times 3 divided by 1 comes out to be 6.5993 moles of CO2. Okay, so I'm going to put that number 6.5993, so round to 3 cent figures. So I'm going to round it to 6.60 moles of carbon dioxide. Okay, now, since I have the moles, let's go ahead and convert that to grams. So 6.5993 moles of CO2. That's carbon dioxide. See? Carbon dioxide. And I'm going to put that all over 1. Open up a set of parentheses. And I need to use a form of weights. So I'm going to go from moles to grams. So I need to use form of weights. So that comes out to be 44.01 grams for every 1 mole. Moles will cancel out. And that comes out to be 290.435 grams of CO2. And I'm guessing 3 cent figures, 290, this is a 4, so that's going to remain the same. So technically that would be about 290 grams. Yeah, if you want, 290.4. So, all right. Now, let me change colors again. I'm going to switch to green. Now, I want to solve for water. Now, water is now going to become B. All right. So now I need an A, something that I know. And I want to use like a mole of A. Well, now I could either use moles of propane, I could use moles of oxygen, or I can use moles of carbon dioxide. I can use either one of those 3 as my starting point. You just have to pick one here. And so the only thing is that, if I'm trying to solve for water and I'm using carbon dioxide, I need to use 3 and 4 with using the carbon dioxide one here. If I'm using oxygen over here to solve for water, then I'm going to use the 5 and 4 using, where's my moles? Okay, moles of oxygen right here. Okay. Or if I'm using propane to solve for water, I'm going to be using the 1 and the 4. And then I would have to use this number over here as my starting point. So I'm going to use the propane again. Just kind of keep things consistent here. So I'm going to use propane. To solve for water. So it's a 1-to-4 ratio, and I need to use this value over here. So scrolling down, I have 2.19976 moles of propane, C3H8. Put that all over 1. Open up a set of parentheses, and I'm going to go from moles of propane to moles of water. So again, it's a 1-to-4 ratio. So I need to use 4 moles of water over 1 mole of propane. Let's go down here. Propane's on top, therefore I need propane on the bottom. So that's 1 mole of C3H8. And I'm going to have 4 moles of H2O. Moles and propane cancel out. So I'm going to take 2.19976 times 4, and that comes out to be about 8.799 moles of water, H2O. All right, so let me put that. So 3 cent figures here will basically round out to 8.80. 8.80 moles. Then, to find out how many grams, I need to use a formula weight for water. And water comes out to be 8.799 moles of H2O. Put that all over 1. And I'm going from basically moles of B, so just solve for moles, went from moles of A, which is my propane, to moles of B, which is now my water. And now I'm going to go from moles of B to mass of B, or grams of B. And water has a mass of 18.01528 grams for every 1 mole. And moles will cancel out. And that comes out to be 158.517 grams of H2O. And if I want that to 3-cent figures, look to the right, I have a 5, but to the right of the 5, I have a non-zero digit, so therefore I round that 8 up. So that will be 159.0 grams of water. So these are the answers. So if you have 97 grams of propane, it will react with 352 grams of water, produce 290 grams of CO2, and 159 grams of water. Okay, now something to show to you here. Law of conservation of matter. The total amount of mass here should equal the total amount of mass that you have here. And let me do a quick little calculation of that. So 97 plus 352. Now, because there's a little bit of rounding, it might be a little bit off. So 449 grams over here. And 290 plus 159. Holy smokes, would you look at that? 449 grams. Hey, these two things are equal, which isn't it amazing how chemistry works out? Now, something else to also point out to you too is if you look at the moles, 2.2, 11, 6.6, 8.8, the ratios of these right here are the ratios of 1 to 5 to 3 to 4, okay? In other words, if you look at 2.2 to 11, 11 is 5 times bigger than 2.2. If you look at carbon dioxide is 3 times bigger than propane. If you look at water, this moles of water is 4 times bigger than propane. Okay, they maintain the same ratios. All right, so I'm going to stop this one. I'm going to try to send this your way, and then I'm going to show you the Sauder stoichiometry, the chart method of doing this. All right, if you have any questions, feel free to send me a message here. I actually kind of enjoy doing this type of stuff. So I'll talk to you later. Bye-bye.